Welcome back. Look, if you're tuning into this explainer today, I know you're someone who likes to live right at the absolute cutting edge of tech. But I gotta warn you, we're about to face a pretty uncomfortable truth. The painful reality? The exact AI skills that made you insanely valuable back in 2023 are basically about to become completely obsolete. We are totally moving away from the era of traditional chatbots, and we're accelerating into a completely new paradigm. I'm leading with this provocative question right out of the gate because, let's be real, I know exactly how frustrating this is. You've been there, right? You spend hours doing what we all call prompt hacking. You meticulously change one single word in this massive 500-word block of instructions, just praying for the perfect output, only to watch the entire AI response just completely break down. It honestly feels like you're trying to cast some ancient magic spell instead of, actually writing reliable software. And honestly, that's exactly why the old way of single-shot prompt engineering is already on its deathbed.
Now, Andrew Ng, who's obviously a true pioneer in the AI space, recently made this massive, eye-opening claim. He points out that, sure, moving from an older AI model to a newer one gives you a nice bump in performance. But get this, that bump is absolutely dwarfed by simply using an iterative agentic workflow. He uses this brilliant analogy that I absolutely love. He says traditional prompting is literally like asking a human to type out a whole essay, from start to finish, without ever being allowed to hit the backspace key. I mean, sure, it might technically work, but it's never ever going to be your best work.
So here's the exact contrast we're talking about today. With the old way, the generative chatbots, you essentially just cross your fingers, send off this one single massive prompt, and hope the AI magically spits out the perfect answer on the very first try. But with the new paradigm, autonomous AI agents, you're actually designing robust systems that can plan, draft, get feedback, and revise their own work. Basically, we're moving away from single-shot prayers and shifting toward highly structured, iterative workflows.
Let's look at the hard numbers for a second, because this is the brain-breaking data that literally woke the entire industry up. What we have here is an older, objectively weaker AI model, GPT 3.5, but it's utilizing an agentic workflow. And it is absolutely crushing the performance of the newer, vastly more powerful GPT-4 model that's just running on a standard zero-shot prompt. And I mean, it's not just beating it by a little bit, it's beating it by a lot. It completely changes the game. The massive leverage here isn't just about having a smarter model anymore. The real leverage is actually in how you architect the system around it.
Section 1. The Rise of Flow Engineering.
This brings us to a huge, totally game-changing paradigm shift. We all have to stop acting like creative writers, desperately trying to coax a language model into doing our bidding. And we need to start acting like high-level system architects. And that is exactly what flow engineering is. The term was actually coined by the researchers over at Codium AI when they were building out for Codium, and it's basically the practice of designing multi-step, iterative workflows. So instead of asking an LLM to solve a massive problem all in one single shot, you break that complex problem down into much, much smaller pieces. You let the AI generate an initial attempt, right? But then, you actually have it critique its own work. You have it run tests, catch its own errors, and continuously revise everything until it finally meets your specific quality threshold.
Let's break down these 4 core agentic design patterns that Andrew Ng recently outlined at Sequoia's AI Ascent. Number 1 is reflection. This is where the AI actually critiques its own output to make it better. Number 2 is tool use, meaning you give the AI access to web search, code execution, or external APIs, so it's not just stuck relying on its own internal memory. Number 3 is planning, which is having the AI break a really complex task down into a logical, step-by-step sequence before it even starts doing the work. And finally, number 4, multi-agent collaboration. This is where you literally have specialized AI agents working together, debating and iterating on a problem. Honestly, it perfectly mirrors a multi-threaded CPU dividing up complex work.
Section 2, DSPy, which is all about programming over prompting.
Okay, so now that we actually understand the theory behind multi-step workflows, we need to talk about how we actually build them in production. We are rapidly transitioning away from manual prompt writing and moving straight into automated orchestration frameworks. You really need to start treating your AI workflows like actual modular software components. And that is where DSPy enters the chat. Developers are literally calling this the PyTorch for LLMs. See, DSPy strips away all of that incredibly brittle, frustrating stream manipulation. Instead of sitting there writing out paragraphs of text, you write declarative signatures, which is basically just a contract saying, here are the inputs I have and here are the outputs I want. Then, the framework uses built-in optimizers to automatically compile and test the best possible prompts for you. But here is the absolute best part. If you want to swap from a massive, expensive model like GPT-4 down to a smaller, cheaper model, you don't have to rewrite a single prompt. No way. The system automatically re-optimizes all the prompts for the new model. It completely shifts your job from creative writing straight into actual data science.
To really show you just how far this automation has come, let's take a look at the complete optimization pipeline of Promptomatics, which was developed by the researchers over at Salesforce. It perfectly illustrates how these modern automated frameworks are operating under the hood. You basically just hand it a plain natural language task description, and then it takes over. It analyzes your intent, automatically generates synthetic training data, picks out the absolute best prompting strategies, things like chain of thought or React, and then meticulously refines those prompts using cost-aware objectives. It literally completely removes the need for you to sit there tweaking prompts manually.
Section 3. Specifications as application code.
So, why does all this matter for the big picture? Well, out in the business world, treating prompts as ephemeral, throwaway communication, that is a massive, massive liability. Regulators and compliance teams, they need to know exactly how your AI systems are actually making their decisions. There's this brilliant analogy from the AWS Builder Center that I absolutely love. They point out that describing what you want an AI to do, the specification, is where the real value actually lives. They say that deleting your prompt while keeping the generated code is literally like compiling C++ into machine code and then just going ahead and deleting the C++ source file. It's crazy. The generated code is just a byproduct. The specification, that structured communication of your core intent, that is the actual mission-critical application code.
So the absolutely crucial takeaway here is that we have got to start applying real, rigorous engineering discipline to these AI specifications. They need to be stored directly in version control, just like Git. You need to embed automated test cases right alongside them. Doing this creates the exact audit trails you're going to need for regulatory compliance and security. Going forward, whoever writes the clearest, most comprehensive specifications using these exact disciplines, they are going to become the absolute most effective programmer in their domain, for sure, because this is exactly how you build institutional knowledge that actually scales.
Section 4. Building your automation engine. We've covered a ton of high-level theory in this explainer today, from stuff like DSPy all the way to enterprise specifications. But I really want to bring all of this back down to massive personal leverage. I want to show you how to build what I playfully call a lazy AI setup. This is a super simple, totally free automated playbook that just logically chains a few tools together. Okay, first you use Zapier Copilot as your automated assistant. You literally just type in plain English to automatically route your incoming emails and tasks. Second, you send all that data over to Notion AI, which acts as your brain center. It takes all that messy data and just beautifully structures it into actionable checklists with a single click. And third, you hook up ChatGPT using custom prompts to act as your writing engine, having it draft out replies in your exact personal style. You are essentially creating a personalized, multi-step workflow that intelligently processes your busy work while you sleep.
And the impact of doing this is just massive. By setting up that exact 3-step automation engine, you can save yourself roughly 20 hours a week. 20 hours! This completely proves that agentic workflows aren't just some dry academic theory for data scientists locked in a lab somewhere. They are massive, real-world time multipliers that are literally available to you right now. Moving from a single manual prompt to a fully automated system is exactly how you reclaim your time.
So here's the final thought I really want to leave you with today. The era of crossing your fingers, closing your eyes, and sending a single massive paragraph to a chatbot, that era is over. Done. The future totally belongs to those who learn to architect automated, self-reflecting, multi-step AI agents. So it's time to ditch the single-shot prompting, start treating your instructions like actual compiled software. And I have to ask, what automated workflow are you going to build first? Thanks so much for joining me on this explainer, and I will catch you in the next one.